Good morning, student. In last lecture, we already discussed the trigonometric function of the complex number. Then today's lecture, we will discuss the hyperbolic functions. Okay. Then in last lecture, we already discussed that sine theta is equal to e raised to I theta minus e raised to minus I theta divided by 2I, and cos theta is equal to e raised to I theta plus e raised to minus I theta divided by 2 tan theta, and so on. Okay, then today's lecture we will discuss the hyperbolic function. Then we have shown that sine theta, sine z is equal to e raised to I z, theta is replaced by z, minus e raised to minus I z divided by 2I, right? And cos z theta or z, we in last lecture we here take the theta. Okay, here we take the z. Cos z is equal to trigonometric function, here we use the trigonometric function, e raised to I z plus e raised to minus I z divided by 2, right? Then if the complex number z is a pure, if that z has z complex numbers y, we know z is equal to x plus iy, x plus iy. But here that x is equal to 0, that means real part of that complex number is 0, that means that complex number is a pure imaginary number. काय असेल, z हा फक्त प्युअर इमॅजिनरी नंबर असेल, प्युअर इमॅजिनरी नंबर असेल तर व्हॉट हॅपन, देन प्युअर इमॅजिनरी नंबर असेल तर हे दोन्ही इक्वेशन जे आहे, इक्वेशन 1 आणि इक्वेशन 2 बिकम्स, काय होतील हे इक्वेशन्स, दॅट साइन here and z is equal to, we are replacing z is equal to iy in equation 1 and 2, right? इक्वेशन 1 and 2 मध्ये z is equal to iy आपण सबस्टिट्यूट करतोय, का तर z हा आपण जो कॉम्प्लेक्स नंबर आहे तो प्युअर इमॅजिनरी नंबर घेतला, त्याचा रिअल पार्ट कसा आहे, 0 आहे. देन वी रिप्लेसिंग इन इक्वेशन 1 and 2 z is equal to iy. ओके, देन इक्वेशन 1 and 2 becomes sin iy is equal to e raised to sin iy, that e raised to z is replaced by I. Okay, that means e raised to iy z is replaced by minus e raised to minus iy divided by 2i. That means sin iy is equal to e raised to I square. I square means that I square is equal to minus 1, right? That means minus y, understood? A minus e raised to I square, I square minus 1 minus plus, that plus I divided by 2i, right? That means we can rearrange or sin iy is equal to I e raised to y minus e raised to minus y divided by 2, right? Then similarly, that cos iy is equal to cos iy, that in equation 2 we replace that z is equal to iy, that means e raised to iy plus e raised to minus as it is I as it is, z means iy divided by 2, right? That means cos in bracket iy is equal to e raised to I square means minus, right? This means I square means minus e raised to minus y plus e raised to I square minus 1 and again minus y divided by 2, right? Then cos I y. Then above equation, that means this equation e raised to this one, okay, this or this, or this sine, this cos. Above functions, these equations or these functions are called as the hyperbolic functions and are abbreviated as sinh. त्याला काय म्हटलं जातं? Sinh, cos, etc. Must remember this, not sin, sinh, cos. This is the hyperbolic functions. That means here we use the last trigonometric function sin theta is equal to e raised to I theta minus e raised to minus I theta divided by 2i, and cos theta is equal to e raised to I theta plus e raised to minus I theta divided by 2. We replace that theta in a z, then equation 1 and 2. But in here z is a complex number, but in that complex number that real part is 0, that only z is a complex number and only pure imaginary number. That means here we use that in equation 1 and 2, we use that z is a pure complex number iy. Then we replacing this, then we got this. This is the functions of the hyperbolic functions, and we abbreviated as a sinh, cos, tan, etc. That means here the hyperbolic functions, that sinh z is equal to e raised to z minus e raised to minus z divided by 2. Cos z is equal to e raised to z plus e raised to minus z divided by 2. Tan z means this one, sin cos z, right? That cosec tan sin inverse of that cosec z is equal to 1 upon sin z, that cot this sec z is equal to 1 upon cos z, and that cot z is equal to inverse of this cos z divided by sin z, sin of z. Okay, you must remember this hyperbolic functions. First one is a sinh. Hyperbolic abbreviation is a sinh. You read this sinh. Sinh z is equal to e raised to z minus e raised to minus z divided by 2. Cos z is equal to e raised to z plus e raised to minus z divided by 2. Tan z is equal to sin z divided by cos z. Then cosec z, cosec hyperbolic, inverse of that sin, sec inverse of that cos, and cot inverse of that, not here, h missing, right, cos, cot, cot z. Okay, that means in hyperbolic function you must remember this, all these formulas, very useful in a complex number, that hyperbolic functions. Okay, in last lecture we already discussed trigonometric functions, all 6 formulas. Then in today's lecture we discuss that hyperbolic functions and we derive this. Okay, understood this? Then in next lecture we discuss the some important identities related of these. Okay, here you must by heard these formulas and must remember all these formulas. Okay, thank you very much.